Acha, in the last class we had discussed about chiral carbon atoms. Okay? Chiral carbon atoms are present in unsymmetric cyclic ring. Let's say this is an entire cyclic ring, right? This part would be symmetrical because if you notice this carbon atom, it will be equivalent to this entire carbon atom. How? If you were to reflect this, ठीक है, अगर तुम अपने फिंगर रखो, एक फिंगर इधर रखो और उसको ऐसे रिफ्लेक्ट करो कि वो सच टर्न अराउंड करके राइट पर ला सको, you will notice it will still stay the same structure. Whereas if you were to compare this part, let's say you're noticing this carbon atom as compared to this carbon atom. This carbon atom has two hydrogens here, right? One bond, one bond. However, this carbon has only one hydrogen here, one OH group. This branch is for this entire part, and this branch is for this entire part, which included this as well. And therefore, it will be a chiral carbon atom because it is attached to 4 different groups. Chemistry of alkanes. Physical properties. You need to understand that carbon 1 to carbon 4 will consist of gases. Carbon 5 to carbon 6 is liquid, and as we keep on increasing, it converts into a solid. Right? Please understand that the percentage composition of carbon is increasing because the carbon content is increasing, as we can see here. And therefore, molecular mass increases. When mass increases, the density increases and the state changes from gas to solid. Right? By the way, gases will have the highest pressure, whereas solids will have the least, and therefore your vapor pressure decreases. For solids, the molecules are closely packed together, whereas for liquids, the molecules will be in clusters, right? Whereas for gas molecules, the particles are far apart to one another and have the tendency to collide with the walls of the container. When they collide with the walls of the container, they exert a pressure. And this is what we use as our base for chemistry, for the context of chemistry. So in chemistry, we do not accommodate the pressure exerted by solids or liquids. We only consider gases to exert a certain amount of pressure, and hence the name vapor pressure. इनमें से सिर्फ gas ही है जिसको आप vapor बोलते हो, right? And therefore gases will exert a vapor pressure. Liquid and solids. Moving forward, reactivity. Because of the absence of functional groups, right? All alkanes are called paraffins, and they will have little. The boiling point of alkanes will increase because of the percentage of carbon increasing. This increases the number of electrons and the strength of temporary induced dipole forces. Please try to avoid the word van der Waals forces. You can use temporary induced dipole forces. I'm just writing down a short form: temporary induced dipole forces instead of van der Waals forces. These are the induced forces because of the presence of electrons. Branch chain alkanes will have our boiling points. We have talked about it before because of the repulsion. Then straight chain alkanes, right? Greater the number of alkyl branches, the lower would be the boiling point. Moving forward, as the number of alkyl branches increases, the strength of temporary induced dipole forces will decrease, and therefore the boiling point decreases because of the decrease in surface area. A straight chain alkane will have all its electron clouds equally spaced out. and there will be minimum repulsion between the electron clouds. Right? However, for a branch chain alkane, if you see, these electron clouds are starting to mix in together, and since electron has a negative charge, they start to repel one another. The same goes for this. They start to repel one another, and therefore their boiling point reduces because they're already in a state of repulsion. They want to separate off. They want to separate off, and a slight heating effect causes them to move further apart. Chemical properties of alkanes. Now, by chemical properties, I simply mean the reactions that alkanes will undergo. Alkanes will undergo free radical substitution reactions. Let's talk about it. Let's say I'm taking an alkane, methane. I'm taking chlorine gas. My conditions required are UV light, or you could say sunlight. Right? Sunlight provides you with UV light, by the way. The products formed would be chloromethane and HCl gas. What really happens is CH4, when attacked by chlorine, the UV light initially breaks more reactive. They attack molecule. Attack the CH fuel, right? Thereby removing other. By the way, you need to understand that this is a chain reaction, meaning to say it keeps on continuing. It does not stop there and then. This chloromethane will further react with another chlorine molecule because obviously you do not have one chlorine molecule in your container. There are large amounts of chlorine molecules. So it keeps reacting until all the hydrogen is removed from the CH4 molecule and you're left with tetrachloromethane, right? This is a chain reaction. Starts off with chlorine. UV light has the exact amount of energy required to break a chlorine molecule. Since it's homolytic fission, I've shown curly half arrows. Right? I will be getting chlorine free radicals. Please understand that this is a bond breaking process and therefore I get an endothermic reaction graph. Moving forward, the chain is propagated. CH4 molecule gets divided into CH3 and hydrogen. Hydrogen being an electron deficient center gets attracted to the chlorine, which is electron rich, and therefore they form HCl. I'm now left with CH3 free radical, which is also called an intermediate, meaning to say a part of the reaction, when a substance is halfway through and has not completely converted into a product, it is called an intermediate. This CH3 is extremely, this CH3 free radical is extremely reactive, so it will attack another chlorine molecule and therefore they form CH3Cl, thereby producing another chlorine free radical. This chain continues. Now the question is, how does the reaction stop? The chain termination. Whenever two free radicals meet together, they stop the reaction. C2H6 is a byproduct of the reaction. byproduct. A product that we had not aimed for, but we get it. Next comes in combustion reaction. Combustion is basically burning in oxygen. So when alkanes undergo combustion in the presence of excess oxygen, you get carbon dioxide and H2O. And in the presence of limited supply of oxygen, you will either get carbon monoxide or carbon soot and H2O. Now, carbon soot is more like a charcoal sort of a substance. If you see any equipment that undergoes heating, you will realize that after some time, there is a certain black material that gets deposited onto it, and that is the carbon soot. Whenever you are provided with an equation, please remember that you need to first balance off carbons, followed by hydrogens, and then you finally balance off oxygen in the end. Okay, if you were to draw a graph of number of moles of oxygen used in combustion to the carbon number, this would be a straight line graph, because you see a proportionate change, a difference of 1.5 throughout. At times in the past paper, they give you a question like 10 centimeter cube of CH4 is burnt in 70 centimeter cube of oxygen. How much volume of gas will remain at the end of the reaction? What you could do is, you're provided with CH4, आपने उसको लिख लिया, आपने ऑक्सीजन के साथ उसको बर्न कर रहे हो, तो मैंने ऑक्सीजन लिख लिया. Now it says how much gas will remain at the end of the reaction. Now, if you see the ratio, it's 1:7 of volume, meaning to say it's plenty full of oxygen. So your product should be carbon dioxide and water. आप इक्वेशन को सिंपली यार बैलेंस कर लो. ठीक है, मैंने बैलेंस ऑफ किया तो मेरे पास इक्वेशन CH4 2O2 gives you carbon dioxide plus 2H2O आ गई. ठीक है. Now this simply means, let's say for example, if I'm using 10 centimeter cube of oxygen, 10 centimeter cube of methane. So according to this equation, only 20 centimeter cube, 1:2 ratio, right? So only 20 centimeter cube of oxygen was required to burn it. And as a result, 10 centimeter cube of carbon dioxide was produced. Okay, they are saying how much volume of gas will remain at the end of the reaction. So if I have 70 centimeter cube of oxygen और उसमें से 20 centimeter cube use हो गई, तो मेरे पास बच गए 50 centimeter cube, right? और उसके अलावा मेरे पास 10 centimeter cube और बच रही है, और 10 centimeter cube produce हो रही है, you could say, तो मेरे पास finally 60 centimeter cube of gas नहीं बच जाएगी at the end of the reaction. Our next topic comes in chemistry of alkene. Right? Now, basic most technique to produce alkene is the dehydration of ethanol. Before I move on, dehydration means removal of water, right? Or loss of hydrated part, you could say, or water content. Since we are talking about ethanol, our reagent should be ethanol, concentrated sulfuric acid, and NaOH. NaOH is a hygroscopic agent, which means a moisture absorbing reagent. By the way, concentrated sulfuric acid and NaOH are kept separately so that they do not neutralize together, they do not react together. Conditions for this reaction required a 120 degrees Celsius temperature, 180 degrees to 180 degrees Celsius, anywhere in between. The catalyst should be concentrated H2SO4. The products formed are ethene and water. So as a result, if you were to take a summary from here, let's say if you are dehydrating propanol, you get propene. If you are dehydrating butanol, you get butene, and so on. The container is kept aside somewhat like this, right? My ethanol and concentrated H2SO4 are mixed together, right? Gas vapor would move through the container. The NaOH absorbs the OH part attached to it, right? And therefore allows dry ethene to be removed from the container. So if I had this equation for ethanol using H2SO4, right, I get ethene plus H2O. The mechanism for this exact equation goes on like, let's say the step 1, ethanol and H plus will react together to give oxonium ion due to the formation of a dative bond. So ethanol and H plus from H2SO4. H2SO4 when breaks down, right, because you are using H2SO4 as a reagent, when breaks down, it will give you these two ions, right? This H plus reacts with ethanol. Ethanol has OH group. The oxygen in OH has a lone pair of electrons which will attract or which will attack the H plus ion, therefore forming the oxonium ion, which is unstable. So to neutralize this positive part, oxygen can only make 2 bonds. The formation of a third bond will introduce the positive sign. So it will remove this bond so that the positive charge is neutralized, somewhat like this. Now you see you have CH3, CH2 plus. Carbon has a positive charge which is unstable. So what it will do is it will ask this carbon to remove the H plus, a hydrogen atom from it. Okay. And in doing so, both of these carbons now have 3 bonds each, which is still unstable because carbon is in group 4 and can make 4 bonds. So to neutralize this, the carbon introduces a double bond amongst itself, thereby releasing H plus and telling us the fact that H plus is acting as a catalyst because it is regenerated at the end. It did not take part in the reaction. It started the reaction and was received at the end. Some other possibilities of the reaction are diethyl ether and ethyl hydrogen sulfate salt. The CH3CH2 plus part reacted with HSO4 minus to give you ethyl hydrogen sulfate. Simply मैं सिर्फ bonds वगैरह बना लो. इसके बाद positive charge था, इसके बाद negative charge था. Both of them made a bond. इसके पास positive charge था, इसके बाद lone pair था. इन दोनों ने bond बना लिया और मेरे पास कुछ डाइथाइल ईथर आ गया.